Right folks, it's the last radio from box 18, so we'll be moving on to box 19 next. So, Fidelity 2000 this time. February 82. Instruction book. No circuit, we know it's a Cybernet 134, and another of those insurance forms from Fidelity where you pay them 10% of what you paid with a minimum of £10 and they insure it against theft. So we will right an original mic. So we'll set this up using the standard test mic, but when we get to deviation we'll just check it with the factory mic which is in there. So make sure there's no crumbs on here, because that's a pretty immaculate set apart from there. Don't appear to be any silly switches on this one. So I'm going to take most of the screws out, but we'll do our test before delving into it. So we've just about had the full Fidelity range, haven't we, this time? We haven't had the 2001. Right, so we'll get it connected to power. Something I do have on here is a Cybernet power stub. We'll connect it up to the test instrument speakers. We'll connect it to the PA speaker. And then we'll connect it to the aerial connection to the test instrument. So it just says on my notes from the customer, service please. So that sounds like this is going to be a set with no surprises. I think it's 11th today. It really doesn't matter what it is. So what is it? 1111 7648, made in Japan. Right, we'll get that connected up to power. I've no worries about switching this straight on at 13.8 because he will have had it on. There we go. Now we want our Cybernet test microphone. Just throw it at myself. Put it on channel 20. Make sure these are in the right position. Yeah. And next, we'll put picture in picture on. And I am recording audio, I can see it, but it doesn't mean I won't have to overdub it. I don't know what happened. So, we're on channel 20. Wow, power output's more than 3 watts. Change scales, it's 3.1 watts. So channel 40, 3 watts. Channel 1, 3 watts. That's well balanced. Low power. It's got to be at the back, isn't it, on these? Low power, 90 milliwatts. That was a flawed test, I was on the wrong channel. It's 75 milliwatts, we'll leave it saying 90, that doesn't matter. And back to full power, 1.015. 1.015 amps. Deviation, wallow. 1.7 kilohertz, that needs to come up. We will be doing the VCO. Let's look at the frequency. The test set's been on for about an hour. Put the appropriate camera on, and it is 2779089. So it needs to come up, but it's not illegally low. Right, we'll dial that into the signal generator. 2779. And we'll have it matching the frequency it's on for fairness. That'll do. Turn the volume up, we've got receive. So we'll put the Cybernet meter on, put the camera on the Cybernet meter, and I'm going to spend half my life resetting these cameras. They move in the night. It's the mice. So 12 dB is 0.47. That's pretty good going. 10 dB, 0.37. And if it will do 20 dB, it is 1.35. Squelch, put it to full. See when that comes in. Well, that's a bit wishy-washy. 10 microvolts. And at the sensitive end, noisy volume control. It's coming in at 0.25. Yes, that's pretty incredible. So when I go into transmit, what does the meter say? This is 4.5, which can't be right because the radio is doing 3. And on receive, we want S9. That's not good at all. It's 4.5 millivolts. Very lazy. Meter lamp's okay. We'll come to switches. That. Check for PA, then we can tick those off. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And that's on. Oh, I've gone and done that, and it's not the right mic, is it? PA function. it's on the volume control's on the mic gain, because on some sets it's on the volume control, some it's on the mic gain, and some it's not controllable at all. Right, so that's gone through the basics. So we'll open it up. That's lost it since you get the bigger speaker, remember, in these. It's the 3.5-inch speaker, not the normal 3-inch speaker that you get on the Rotels. So I'll just look for dodginess. I can't see any dodginess. Smells of fags. Right. So we'll start with the VCO. I'm borrowing Mr. Chip's crocodile clip lead. Gone resistor 4, which it looks like it's never been prodded before in its life. We need to go to channel 40. .16. And then transmit. .63. So that needs to be a little tiny bit lower on receive. It's supposed to be 4. This is really neither here nor there. Supposed to be 4, so it's not fun trying to prod through this wax. That is 4 volts exactly. And on transmit, let's see whether we've affected transmit. That needs to come up. So it's the red trimmer just there. All we've got to do is to hold that on, press transmit, and adjust this at the same time with our 3 hands. Receive 4.01, transmit, we'll say 4.06. So we'll just, I'll put that away. And we'll just do the frequency. So go over to the frequency counter, make sure we're on channel 20. And hopefully bring that up. Yes. I forgot to check channel 1 on the VCO. I don't write that down, that's the why I forgot. So we'll just pop it down to channel 1. So in receive, it's about 1.9 to 2.4, something like that. Oh, my negatives come off. No wonder I'm not getting anywhere. .23 and in transmit. 2.28, that's bang on. You know what, if I hadn't have checked that, it would have been wrong, wouldn't it? Right, we'll go through the transmitter. Being attacked by a mad tool. So we'll be in the 4 watt, in the 30 watt scale. So 4 watts is there, and at the moment we're just doing 3. So I'll just make sure this is on channel 20 because it wasn't. That's definitely correct as it was. That's correct as it was. That's correct as it was. So presumably this is wrong. So as I said before, these are temporarily peaked to absolute maximum. Because this can't support, supposing we can get 5 watts out of this, it can't support that. So legality side, obviously your legal limit's 4 watts. But legality side, the radio can't support it. And I've seen these left in 5 watts, and then you start with problems with blown output transistors, and it's just an expense which is unnecessary. So at the moment that's 4.6. You know what, I don't think this set's ever been fiddled with. That's a perfect response to what I'd expect of a factory set. Okay, so now with it doing 4.7 watts, we need to drop this by turning it clockwise till we get 4.4 watts. So it's clockwise for 4.4, and then anti-clockwise with the green one until we get, they say 3.8 watts, but of course they're trying to get new radios through customs, and we're allowed 4 watts. So we'll turn it to 4 watts, just like that. So now we need to check that it's within 0.1 of 4 watts on channel 1 and channel 40. Sometimes you can't get that, sometimes it's 0.2. So, channel 40, it's 4.0 something, and on channel 1, it's 3.9 something. So, it's 4 watts, it's 3.95, it's 4.05. So we'll do low power. So we'll now change scale to the 3 watt scale. I think we've got a dirty preset there. We'll just wiggle that around a bit. And there's 400 milliwatts. Just check we haven't got a dirty switch. I'll tell you what, we're going to spray that as well. Of course, in recent sets we've had the switch playing up as well. It might be the latest trend now, they're 42 years old. Yeah. So we've set that for 400 milliwatts, and now the radio draws 460. Yeah. I'm being attacked by some mad instruments because I caught the leads with the edge of the clipboard. Right. So that's now 400 milliwatts, 0.4 of a watt. And if we go back to high power, just draw 1.094. So for that extra power, we've got not a lot more current being drawn, which is pretty efficient. Shows how I've improved the efficiency by doing the tune. So next we need to make sure the meter says something like So it's reading 5, so we'll just adjust that till it reads 4. So that's that done. And then we do deviation. So I want the vertical one to be in its central position. They're not the easiest things to work with, these type. That looks to be the central position. Now we'll do the deviation with the horizontal one. Wallow. So it's not quite there, it's come up a bit. Let's try it there. Wallow. Testing 1, 2, 1, 2, wallow. A fraction more. Wallow, that's it. Now we're going to just check the factory original mic. I'll put our monitor receiver on so we know if it's got any breaks in the mic lead. Oh, it reeks of fags, this does. Testing 1, 2, wallow. 1, 2, wallow. It's a bit less sensitive at that. I haven't got mic gain at full, I have to recheck this. Wallow. We'll bring back the oscillator. Wallow. Spot on for that mic. Might just be a little over the top on our standard mic. Wallow. It's very exciting. I'm going to have to knock that down a fraction. Wallow. That's now fine. So it's going to be about 2.5 and a bit absolute peak with that, and 2.4 absolute peak with the factory mic. So we'll carry on with that. And that concludes the transmitter. So moving over to the receiver, put the oscilloscope on, put the camera on the oscilloscope. So it's already working very nicely, thank you very much. Now we've put the radio on frequency, we'd better put the signal generator on frequency. And that's now spot on. So just check that this is at peak. This is the detector. No, it wasn't. So that's an improvement. Right, we'll drop the signal, go over to the Cybernet meter. And we'll go for 4 dB on there. I'm actually going to have to go down a scale. So I'm on the 0.3 scale. We've got a fraction out of it there. No, that's spot on as it was. Spot on. Could be a fraction there. Put a bigger signal on for that. So apart from that and the detector, that was spot on. We're done. So we'll get a new reading for 12 dB now. And let's go over to the attenuator. No, we'll keep it on there so you can see I'm doing 12. It's now 0.35. So the 10 dB, 0.27. And if it will do 20, which I think it will, looks to be 1. Check it on the other scale. We'll say 1.1. So we just need to now check that the S meter reads S9. It was not quite where it should be before, so that's the S meter. Yep, that's now reading where it should do. And now we'll do the squelch. So with the squelch to full, that volume control needs spraying. We'll do that while I remember. So I want it to still be closed at that position. And it should open. Let's put the attenuator on here. So there's 30 microvolts. I want it to open at 100, which it now does. So that's where I want it to be at its tight position. And at its most sensitive position, we'll put the signal generator to standby. It's parked at 0.3 microvolt. Drop the squelch, select threshold, switch the signal generator back on. Let's see when it comes in. It's coming in at 0.61. It's leaving about 0.51. So now 0.61 and 100 microvolts. So that's now right. That's now reading 100 microvolts. That's right. Just check the channel 9 switch works. So dimmer, yeah. Channel 9, yeah. Let's listen to the tone. Yeah, that works. So they're done. Sockets work. That is a retune and test. So I've sprayed a few things. That's no repairs, just a bit of maintenance and a retune. And that is lovely. And don't forget, these Fidelity thousands cost less to buy on eBay. Because, oh, it's Fidelity, they're rubbish. Well, they're not. It's a Rotel 230 in a different case. I just wish I'd put a little bit more wire on that speaker connector. Right, we'll unplug that. Yep, internal speaker's working. Turn picture in picture off. Put the screws back in. And we'll do an on-the-air test. That screw does not want to go in that hole, so we'll put it in that hole instead. Right, we'll have a flick round. It's Saturday afternoon, about 2:30. Put it on the aerial. Turn off the test gear. Greeted by stuff which shouldn't even be there. One and a Roger. Nothing. One and a Roger. Nothing. There we go. Fidelity 3000. Nearly gave it the wrong number. Lovely set. Thanks for watching.